So this is your standard question when it comes to chemistry calculations. This is a yes, but obviously when you know how to do these, A2 or second year of chemistry, A-level chemistry shouldn't be too hard. So here they've given us the sort of values here. So they've given that, and it says calculate the mole in moles of NaOH. They've given us this big equation here as well, which might be useful. So might be useful to sort of like, you know, see that, but then again you need to see what they're actually asking you for. So here obviously it says the number of moles. It's only a one marker, which shouldn't basically take you more than 30 seconds. It's all right if it can take you a bit longer than 30 seconds at first, but then obviously on it shouldn't be taking you more than 10 seconds. Okay, so let's start this question. So they've given you the volume. So they've given you the volume, they've given you the concentration. Always write down what they've given you, sort of just to give you exactly what you, to sort of like just let you know what you have already. So they've given you the concentration, they've given you the volume as well. Always remember that there's one specific formula for moles. Whenever you want to work out what moles is, it's C times V over 1,000. Obviously, it's only over 1,000 if the volume is actually in centimeter cubes, to sort of balance that out. So here we have 25 times 0.088 over 1,000. The answer, after plugging it into a calculator, should be 2.2 times 10 to the power minus 3. That's the answer. Only one marker, more or less, just took less than 10 seconds, I should say. Okay, then it says determine the amount of moles in H2SO4. Remember the lovely little equation they gave you here? Well, guess what? We're going to use that here to make our lives easier. I mean, you could just work out the number of moles of H2SO4, but remember they have only given you the volume, they haven't given you the concentration, or they haven't given you anything else. So your best bet is to just sort of use this big formula they've given you, because remember, you're not going to get, they've already given you what you already need to know in the exam. Okay, they're not going to just give you random pieces of information and like expect you to work out random pieces of you know. But anyways, so we have 2.20 times 10 to the minus 3. This is the answer. Now in this one, right, they've got a ratio of 1 to 2. Okay, remember the NaOH is 1 to 2. Sorry, it's 2, and then the H2SO4 is that one, which basically means that 2.2 times 10 to the minus 3 is for NaOH. So if we've got 2.2 times 10 to the minus 3 moles of this one, just divide that answer by 2, you can easily get the moles of H2SO4. It's not really, you don't need to be Einstein to work that out. So anyway, so that's 1.1 times 10 to the minus 3. Okay, and then it says calculate the concentration of the sulfuric acid. So now you've got the number of moles. Okay, remember, always go back to the formula that you already have. The formula is C times V over 1,000. So they've given you, so you need to work out the concentration. They've already given you the moles, they've given you the volume as well. So remember, the volume is here. And then they've given you, so they've only given these two, or you've sort of had to work that out. They've given you this, you only need to work out the volume. I should sort of uncircle that. So all you need to do is rearrange the normal formula. N times 1,000 over C is equal to volume. In other words, oh sorry, I should sort of turn that out. Okay, meant to say, okay, can't do that. So V equals C. So long story short, you just plug 17.6 times 1,000, divide that by no, that's wrong. 1.10 times 10 to the minus 3 times 1,000. Them two cancel out. So that's 0.0625. You are allowed to take a calculator in the exam, so it's absolutely fine. That's your moles. Okay. After carrying out the titration in part A, the student left the resulting solution to crystallize. What crystal will form with the formula of this and a molar mass of 322.1. What term is given to the X part of the formula? Well, that's pretty simple. It's not really hard. You should be knowing this because it says it right there in your textbook if you bother to read it. It's the waters of crystallization. Whenever you see this symbol here, okay? Whenever you see this symbol here, sorry, I should say this one, that's waters of crystallization, okay? So that's your second sort of part. Now it says using the molar mass of the crystals, calculate the value of X. So they've given us the 322, so I'm going to sort of just go back and forth because I may not remember. So it's 322. So it says 322.1. That's the molar mass, and they basically want you to work out the value of X. So all you need to do here is that if you go back, okay, you need to work out that the Na2SO4 basically just adds up to, if you just basically just calculate that, where is it? Yeah, so if you just work that out, so Na is, I think Na is 23. I might be wrong. Let me quickly double check because I don't have a periodic table in front of me. I know. Oh God, this is embarrassing. How can I forget the molecular? Yes, it's 23, or just about 23. So it's 23. Obviously, you know your basic maths when it comes to this. So, 23 times 2 plus sulfur is 32.1, I believe. Let me check if it's sulfur. Yeah. And then that's 16 times 4 because oxygen is 16. I'm going to quickly go ahead and use calculator because I don't know how to do this. Joking. Just I can't be bothered to use a calculator. And then 64. Okay, 142.1. I should have known that. That's so stupid. 142.1. Then, using your quick maths, you can easily work that 322.1 minus 142.1. Okay, sorry. So you should know that obviously that minus that is basically equal to 180, I think. Yeah, it should be 180. And then obviously because the molecular mass or the MR of water is 18, remember, H2O, 16 plus 2 is 18. So you divide 180 by 18 and that gives you your X value, which is 10.